Welcome into the show today. So excited that you've joined Ask the Masters. My name is Dave from Fluid Dynamics, and this is the first official kickoff of Season 2 of the show. Today we sit down with Dave Peterson. Dave Peterson runs Watershape Consulting, which is a engineering firm based out of Solana Beach, San Diego, California. And Dave is both a structural engineer and a hydraulic engineer. He's actually also a civil engineer. So we talk a little bit about dispelling some of the myths with engineers and working with engineers. Here in California, we work with engineers on all of our jobs, but I know in a lot of places throughout the country, people don't work with engineers. And so we wanted to explain some of the reasons why you might consider working with an engineer, and then some of the benefits, what an engineer would need from you information-wise in order to properly engineer your project. It's a really great conversation that Dave and I have, and hope you enjoy it.
You do not want to miss the next lifestyle event with Ask the Masters on February 27th and 28th. We are being hosted by Bazaza Tile, Laticrete, and Wet Edge, and we're going to get dirty. We're actually going to install paper-faced Bazaza Tile with the backdrop of Laticrete, all at the Wet Edge facility. Enjoy.
All right, welcome to the show today. My name is Dave from Fluid Dynamics, and we have our good friend Dave Peterson from Watershape Consulting back. Today we're going to talk about engineering. Dave and I work together on a number of projects. We do a lot of hydraulic engineering and structural engineering of a lot of projects. One of the things that around the country, many pools are built without structural engineering. Here in California, every permit requires a stamped set of structural engineered plans for every job here, but that's not the norm throughout the country. So let's just get into a little bit for those people that are not familiar with working with an engineer. Why would you have engineering, and also if you're contracting with a pool contractor, what's your thoughts on allowing a contractor to self-engineer a pool and things like that? So, but let's start off with kind of what's involved in structural engineering. What are kind of some of the minimum requirements, and what is how do you view that as an engineer?
Yeah, well, I guess the first part is, where is engineering required and where is it not? And I think I would probably sort of pose a question, to the audience or the architects out there and say, would you design a house for somebody without doing engineering on it? Mm-hmm. It doesn't mean you need an engineer necessarily, because an architect can do structural engineering for, a project like that. But you wouldn't feel comfortable sleeping at night worrying about whether the roof was going to fall in on you.
Right.
And so you're required to get engineering for your house, and in some parts of the country, you're required to do that for a swimming pool as well. Now, that's not always the case, because most pools, when they fail structurally, it's not a catastrophic failure. Right. Nobody's dying because the structure imploded or fell down a mountain. I mean, that's a pretty dramatic thing to happen. So it's not always required, but that's a big mistake in my opinion, because doing expert witness work all over the place, all over the country, we find projects in areas where they weren't required to do structural engineering. They might not have even been required to do a permit other than maybe an electrical permit. Some of our cases are ones where the only requirement was that the contractor called up an electrician to put a sticker on the electrical panel.
Wow. And
then the inspector comes out, and if he sees the sticker, he says, you guys are good to go. You can swim in the pool now. We found electrical problems on those projects. So clearly the person putting the sticker on doesn't understand Article 680 in the code. So problems all over the place. But structurally, it's a good idea to have it figured out anywhere. Now, that could be a standard plan, or it could be a custom plan engineered specifically for that project.
We've taken the position that every one of our members needs to have site-specific structural engineering for every one of their jobs, whether the municipality is requiring it or not. So that's one of the things that we hold our membership to. But you mentioned a couple of terms. Let's kind of get into that a little bit more. Custom engineering, site-specific engineering, standard plans, all of that. It can get a little bit confusing for people that are not familiar with the terminology. Mm-hmm. So let's kind of start at the bottom of the hierarchy there with your pre-approved standard plan, and kind of explain what that is, and then all the way up to full custom.
Yeah. Well, when you say starting at the bottom up, I think you're sort of focusing on it from a cost standpoint, because
Sure.
the least expensive way to do the structural engineering would be to buy a pre-approved plan, where it's basically a sheet that's got a series of tables on it, and some generic sections and dimensions in there. And so really the builder could call up and say, hey, I'm going to build 10 pools this summer. Send me 10 copies of that sheet, which has already been approved in the city that they are planning to do their work in. So they do a site plan, staple it to that sheet, and go get a permit. Over the counter in many cases, because the engineering has already been approved. So the only thing you're doing at the counter is making sure that you've set the pool back, from your setbacks, and you don't have any easements running through it or something like that. So it's really more of a planning department issue as opposed to an engineering department issue, because you have the engineering pre-approved.
Yeah, one of the limitations to that is that really, at that point, it's all on the contractor. It's all on the person that is stapling that plan to certify the soils and the positioning. So the engineer that sends out that plan it has not inspected the site, has not looked at the soil conditions, has not reviewed a soils report. So really, from that standpoint, the liability all really relies on the contractor at the end of the day.
Right. And they're often not getting the soils report and missing it. I mean, I've had cases where somebody bought engineering from a company that has valid calculations and everything to back up their sheet. The problem is that they didn't get the soils information that would have told them the EFP was 120, and they're reading off a plan where it maxed out at 60. I mean, they were only getting half of the equivalent fluid pressure of the soil pushing in, and that active pressure being half, and building it to that standard, and then finding out later, once it rained, that the soil was just going to crush the shell, turned into a lawsuit. So.
Yeah, and that's not really necessarily on the engineer,
right.
Because the contractor did not do due diligence to understand the condition that he had, and yeah, the pool shattered, but of course it is, because it was the wrong engineering.
Yeah.
So that's the real limitation that I see with pre-approved engineering details. So I would the next step up is going to be kind of your standard plan. Kind of describe that a little bit.
Yeah, well, I would say that the next step up from that would be you could use a plan like that, but you could meet with the engineer and say, here's my soils report, and if there's other details that are needed, the engineer could pull things together and try to build a set. But that does get a little confusing, because oftentimes you've got the standard plan that's been approved by the city. You may have additional details which may or may not have been approved by the city. And then the really confusing part is that you're asking the builder to interpret different things. Like, well, this section's telling me to do this, and this one's telling me to do that. And do I add that steel together, or, this one just requires one more bar? Do I just add the one bar to this detail to make the two, coincide with each other? So that gets a little bit tricky when you're trying to marry up, 5 different standard details into one.
Yeah, because on a standard or a pre-approved set of plans, there may be 6 tables, and so at 3.5 feet deep, there may be different schedules at that depth, because they're trying to cover numerous different situations. And so, again, it's back on the builder to understand which column within that table is appropriate for the specific job, and then you add in additional details on top of that, and which one are you following, this table in here, or which column in this table over here. So it does become, and for a homeowner or a design professional, it can be really quite confusing.
Right. So, but the benefit of actually sitting down with the engineer and saying, let's take your standard plan and let's add in whatever details and marry that, of course, to the original soils report and the site plan and the plan of the vessel. At least the engineer at that point can kind of see everything. He can look at the soils report and say, well, the EFP here is 90. So this plan isn't going to work at all. We got to get this other sheet and with the higher EFP, or maybe it's another detail that adds steel to the base plan or something. So at least at that point, the engineer is now sort of pulled into it and a little deeper, and they do have to do a little more work to figure it out. But you can walk out of their office with a series of things that will apply more specifically to that site. Maybe you can still pull the permit over the counter. Maybe the additional details require it to be submitted, but usually it's understood that it's a pretty quick process with pre-approved plans at least.
Sure, and there are some good details out there. Some of the things that I have seen missed before is that so many times the contractors go in with their site plan, but they have not detailed what's going on 15 feet on the other side of the property line. And it may be a cut lot and you've got a cliff on the backside, or a one-to-one slope going back down. And the engineer, if that's not delineated on the plan, is maybe not taking that into account. And so it's really important that if you're going to go that direction, you need to really take a holistic approach. If there is a downslope and you're trying to set the pool right out next to the downslope, I don't need to know that where the property line fence is 4 feet down. What if the bottom of the hill is 200 feet down? Mm-hmm. And we actually were on retained on a job probably about 10 years ago, and they had already worked with somebody to pull the engineering, and it was completely inappropriate because the bottom of the ravine was 140 feet down, I think, but that was not accounted for in there. And I came back to the client and said, this pool needs to be on caissons. And the other builder disagreed and said, no, we can just do a deepened keyway. And that was the big limitation. We ended up not building the project because it was the plan set was not complete enough. So even though the engineer knew there was a hillside there and everything, didn't have enough information.
This segment has been brought to you by
Watershape University.
Welcome to Season 2 of the Ask the Masters. Today is our first official podcast, and I am really, really excited to announce that Ask the Masters is partnering up with Watershape University this year. And today on the phone, we have the VP of Watershape University, Lauren Stack.
Hi, yes, Lauren Stack. I'm the Vice President of Watershape University, and we're only 5 months old, but we have just a growing stable of brands and things that are important to the industry. First, Watershape University itself delivers high-quality live instruction, technical, many disciplines really, including business, design, engineering, and construction. We have very talented faculty on our staff, and excited to bring that education to you. And as you spoke, we will be kicking off our spring season, and we'll get into that a little bit later. Another aspect is the International Watershape Institute, and this is really the home for the leaders in the industry, those that have gone through our curriculum, who are influencers, who are coaches, mentors to other students in the system. They're also ones that teach. They're the subject matter experts. And we're really excited to have their home in the International Watershape Institute. And watershapes.com, which was an acquisition that we made in the fall, it is a digital asset that most people may be familiar with, or should be at least, because it has a vast archive of technical papers and articles that are very instrumental in helping people develop their technical skills. We also, that asset is an e-publication that goes out twice a month to many, actually tens of thousands of members of the professional community, landscape architects and architects. So that is very important to get exposure for our IWI members, and that's why it's kind of a closed cycle within all of Watershape University. And then just real briefly, I'll just mention a very exciting aspect of our business, which is the Live Blue Foundation, and it is a partnership between Watershape University and Wallace J. Nichols, and it's a 501c3 nonprofit with the goal of getting people near, in, on, and underwater for life.
Yeah, the two things that I'm super excited about. I mean, I love the whole idea of Watershape University, and I'm going to be teaching starting in the spring semester. I'm going to be teaching a class with Watershape University, and obviously, I love education. I mean, from an aspect of the educational background that I have, and being able to become an instructor and part of the faculty of the university. That's really exciting for me. I love giving back. Obviously, that's what this podcast is about as well. So I'm looking forward to that. But the whole Watershape magazine, that is just so, it's such a wonderful acquisition. When I heard that you guys had acquired that, I was so excited to hear that. It's kind of the Bible of water shaping and architecture, dealing in and around art. You know, I remember years and years ago when it was still in a printed format. I used to crave every time the magazine would come in, and the day it would get delivered, probably within 4 hours, I had the entire magazine consumed. And I still have those archives, and I still have those sitting on my bookshelf. I know exactly where they are in my office. And I can't tell you how many people I talk to that also have those. It's just, there's so much quality information in there. So I was super excited to hear that you guys had acquired Watershapes magazine, because it's such a great asset. And then, as you and I know, we're working with the Live Blue Foundation, and that just, for me, that's a passion point. I'm so excited to see that partnership with Wallace, with Jay, as everybody knows him. That's just going to be a great partnership, and I'm really excited to see where that goes, and really getting the pool industry really deeper involved in the whole Live Blue Foundation and that whole Live Blue and Blue Mind movement. To me, I can't wait to see how that develops over the years.
Yeah, I think Jay's helping us come to terms with the fact that pools are really the gateway to the world of water, and that, you know, we need to embrace that as an industry, because without us, people don't know how to swim, they don't know how to surf, they don't take that next step into water activities without being comfortable around it and being able to swim. So it's very important to us.
So let's get back to kind of the meat of what we're going to talk about today. We'll have many conversations throughout season 2 talking about the different aspects, and we're going to get into a little bit more in depth about Live Blue. But today we really wanted to kind of announce and talk about the upcoming spring semester. And so this is spring 2020, and everything is debuting here in March, on March 1st. So could you kind of bring us up to speed what you got coming in the first quarter and here in the spring as you guys start your educational classes this year?
Yeah, thanks, Dave. Our first school this spring will be March 1st and 2nd. It's going to be in Marco Island, Florida, and it's a 2-day business school, which is it's a new school, actually, being taught by Peterson, Bill Drakely, Julie Kasdan, and Paul Oman, and so that's going to be exciting. Then we'll be out in Long Beach, the Western Show, and we'll be have a physical presence there as well as a class, and that's cost estimating. And this was a very popular course that was offered at the International Show in New Orleans this past year, and in the fall, and we're excited to bring it to Long Beach, so that's good. And we're also very excited about 2 short courses, 1 day each courses, that we are bringing to the MPG outing in Birmingham, Alabama. So for those folks in the Southeast who are looking for good education, we have 2 options coming up. First is our Construction 2121, which is Introduction to Site Evaluations and Surveying. This is very much a hands-on activity type related course where you're learning things in the classroom but then applying them in the lab, if you will, using equipment. So that'll be fun. It'll be taught by Peterson and Ryan Oakes, who's another one of our IWI members. And the second short course, again, it's an 8-hour course, which is reinforced concrete water shapes. So learning the key structural concepts, compression, tension, shear forces, all those types of things, and how that impacts your steel design and how you install it. And looking for code requirements and all the reinforcing standards that have to be applied to pool structures. So that's a very important course for people, and taught by experts, people that, Bill Drakely he's leading the committee on pool structures within the American Concrete Institute. So he's writing the standards. You can't learn from anybody more in tune to what's going on than Bill Drakely.
Yeah, and that dovetails real nicely with the episode that we're listening to today about structural engineering and everything. So it's if this episode that you're listening to today is piqued your interest, you really want to sign up for that class. It's coming up March 17th, 2020, and that's going to be the reinforced concrete. And how can we get to it? How can we? Where's the sign up page?
Just go to go.watershape.org. Or just go to watershape.org and look at our curriculum page, and you'll see the ability to get in and register for those courses.
Yeah, and if you want to go directly to the reinforced concrete page, it's go.watershape.org/MPG for Master Pool Guild, MPG2. And that'll take you directly to the page where you can sign up right online. And again, those classes are coming up in Birmingham, Alabama, March 16th and 17th. And then we chatted about it a little bit, but I'm also super excited. The Western Pool and Spa Show in Long Beach, that's where I will be teaching. Dave's offering the cost estimating class, which I took in the fall at the International Show. And I can't encourage people enough. I mean, that class will sell out, absolutely, hands down, without a question. The class itself is worth the price of admission. But what you get with the class is you get the software. And the software, again, to me, it's like it's a 2-for-1. You would pay that much for the software. You would pay that much for the class. You're paying once and you get both. We've started implementing the software within my company, Fluid Dynamics, and it's changing the way we do everything. So that class is going to be great. I'm super excited to see that being offered again this year. And then I'll be teaching a short course on transitioning from the service industry into the construction industry. We've done that at the Western Show the last couple of years, and we're going to be making some changes to it and kind of fine-tuning it and adding some modules to it this year. So it's going to be a different show. So if you've taken it in the past, this year is going to be different. And if you found it helpful in the past and you want to take it again, it's not going to be a repeat. There's going to be a lot of different information and everything in there. So I'm real excited about that. So Lauren, thank you so much for joining us today. I'm so excited to explore this relationship that we're going to have between Ask the Masters and WaterShape University. And I'm really excited to kind of use this platform to allow people to understand more and more about WaterShape University, all the different facets of it. And so look forward to next time when we get together and chat about some of the other things. And I really want to thank you for coming on today.
Well, thank you so much, Dave. We too feel the same way about ATM and look forward to many great things in the future. All
right. Thanks for joining us.
Thank you.
Bye-bye. So let's deviate just a little bit here. We've talked about soils reports a couple of times now. Why, as a structural engineer, is a soils report so important? Why is that? Why do you keep referring back to that?
Well, the soil is the foundation for the pool. So you have to know what the pool is sitting on. And that's really what's going to tell you whether you can do just a standard shell in the ground or whether you need to over-excavate and backfill to solve a problem. Maybe you're just over excavating a part of the pool. We had one of these where the whole pool was pretty much in really good DG except for one little section of fill in the deep end. So when I had our soils guy go out to sign off on everything before we started putting steel in there, he said, you know what, let's just go take that out, we'll slurry it in with concrete, then we'll do the steel. So we were basically replacing some fill with concrete in this DG soil profile. And at that point, I knew that the whole pool was sitting in such good dirt, we were never going to worry about settlement or anything like that.
Sure. And what's the process of getting a soils report for somebody that's never done that? What generally is that? What's appropriate? What's not enough for you? What do you want to see if I'm coming into your office with a soils report? What are kind of the minimum things, and then what would be the ideal that you would want? Let's talk through that.
Yeah, well, the ideal thing would be actually a soil boring, and maybe 2 of them if the pool was big enough that maybe you could have different soils in different areas, especially on a lot of these lots where there's cut fills and transitions that we need to worry about. Might be good to take one on the house side, which is often different from what may be out at the end of the property.
Close to the slope, yeah.
Where you might have a bunch of fill, and then knowing based on those boring logs what you're dealing with, because then you could look at it and say, well, yeah, if maybe we put the deep end over here, and maybe we just put a little key on it, and it actually affects the design of the pool. Or you say, well, that doesn't fit the architecture at all. We need to turn the pool 90 degrees, and now because of the soils, we need to put it on caissons or much bigger footings or something like that. So it really starts to drive design decisions, and then of course the structure itself. And we won't know any of that until we get all that detail. Now, if it was a more simplified pool, maybe we don't need that. And I can actually call up our soils guy in San Diego, and I can talk to him on the phone, and he's got a lot of soils maps. He can actually look stuff up right there and just say, you know what, based on this soils map, I think this is what we're going to find when I get out there. And I say, great, that's enough for me to start this process. There's nothing scary yet, and then we will go have you take a look when we get further along, because further along for me means I want to get drawings to the point where I can put a bid together. And if the assumption is that there's not going to be a foundation because it's a pretty simple project, then I could put a construction proposal together for that based on standard, non-foundation type of engineering, in the ground, shell in the grade. Once we get further on, then of course I have the soils guy go out there, and sometimes on those jobs it's after excavation.
Sure.
We dig the pool out, he'll come out, get in the hole, do a field report. I pay him $800, and I get a report of all the stuff that he's seen there. And if he wants me to over excavate or something, or if he sees something and it's like, whoa, time out, we got a big problem, at least I'm only into it the cost of the excavation. I can go back to the owner and say, look, he just added a $40,000 foundation, so you could pay the 40 and we can keep moving, or I'll put the dirt in and we'll split the cost,
right,
because you knew what the risk was. I took a risk, and we'll work it out together. But at some point, you have to assess where the client's temperature basically, and what's their ability to handle that kind of risk.
Yeah, and I think it's real important to be having those discussions very early on with clients, that they kind of know going in that, hey, this is way it's going to go. We're going to do this. We're going to have the soils guy come in, and just let them know that, a small percentage of the time they're going to come out and they're going to find something that's like really
major.
Yeah, and it's not going to, you're not. It may derail the entire construction project. So, yeah. Just a quick story on that. We had a job that the client is in construction, and so he pulled his own permits, got his own engineering, got everything, chose not to get a soils report, and then basically gave us the permit set and said, please price it. And we dug the pool, and the deep end of the pool ended up being, we just got down into this, the original plane. So it was a newer construction area, so it was a lot of fill and everything. So we broke through all of the fill to the place where we actually found an underground river at the plane between the native soil and the fill soil. And there was literally a river running that, had the pool been 6 inches shallower, we may not have seen it. And brought the soils guy out, and again, he stopped construction, said, we will not certify this. And the client ended up costing about $25,000, $30,000. They overdug the entire pool, poured 100 yards of slurry in there, and then we built the pool on top of that. Fortunately, the client had connections to get some of that done at a reasonable rate, but That's a story that I tell to my clients a lot of times about, hey, this is why you should consider getting your soils engineering up front, especially if your budget is really tight and a $20,000 change order is going to derail the project. But what is the anatomy of a soils report? One of the things, even before we go there, you do a lot of times what I do as well. I have a soils guy that I work with locally. I've been working with him for 15 years. He looks at every one of our jobs, except some of our bigger jobs. And some of our more simple jobs, even just a little spa, I have him come out and do a bottom inspection and just look at it, make sure everything is fine. He writes a letter, says, he certifies it. He's got his little nuclear tester, and he gives us the compaction, the density, all of that right there, and away we go. And it's not that much money for him to come out, and since we do it so often, many times a year, every pool we do, he sees the bottom. I can also call him up, and I've called him up before and said, okay, here's the address, and he said, north side of the street or south side of the street, and so they understand the overall the general area that they're working in, and they can generally tell you, once you've built that relationship, yeah, this neighborhood is a problem on this half of the street or in this particular area. So that's a real critical piece, I think, to build that camaraderie and that understanding with your engineer. So back to my question, what is your, what's the anatomy of a soils report? Obviously, to tell you the expansion coefficient of the soils. Soils guy is not going to miss slopes and all of that thing.
Right.
Some of those kind of things. Any other thing that you really want to make sure that you're getting from the soils guy?
Yeah, I mean, that plasticity index is telling you whether that soil is going to expand or contract when it's subjected to different moisture conditions. And we're looking at, also the bearing capacity. That plasticity index affects things like the active pressure of the soil and the passive pressure. And that's what we really need to figure out, how hard is the soil going to push on the pool. And for a lot of these hillside jobs, if the soil's pushing on the pool and maybe we don't have dirt on the other side, maybe that's a vanishing edge. Or maybe it's a pool in the ground, but there's a raised bond beam. So I've got active pressure that's higher on one side of the pool than the other. Well, now we have to have passive pressure on the other side to resist that. Now, if both sides were even, you're just squeezing your pool and it's not going anywhere. But if all of a sudden you've got more soil on one side, then you have to start thinking about sliding and tilting, and is that going to cause differential settlement, and how is that structure going to interact? Some are not really much of a concern. Other ones, depending on the shape of the pool and everything, all of a sudden it's like, hey, we got to focus on this, and we start looking at heel pressures and toe pressures, and really looking at things like retaining walls, which are often part of our projects anyway. And we just want to make sure that things are going to be stable. And when you start getting into things like vanishing edges and things like that, then we start looking at what is the expected settlement or differential settlement that we might have. And if the soils engineer said, well, look, I expect 3/8 to 3/4 inch even settlement over the next 3 years, then that's something we could deal with, maybe with the edge detailing. Maybe it's a thick piece of granite that could be ground and polished if the thing came out of level. If an engineer said, a geotechnical engineer said they were expecting 2 inches of settlement, then I would start saying, well, maybe we shouldn't even try an edge detail. Maybe we should look at a standard pool, or go to caissons or timber piles, helicals, some other way to provide some vertical stability to the structure.
Yeah, and differential settlement, I think it's a little bit of a bad name. It's a bit scary. We can design, you can design pools to handle a certain amount of differential settlement, and if it's a small structure and we create a rigid enough shell, if it settles a half an inch, that can be accounted for in the engineering. But a vanishing edge pool that settles a half an inch, you're having flow problems and everything. So it can really start to inform the design decisions as well. You know, you can come in and have this beautiful vanishing edge pool, decide that the client doesn't want to pay for caissons to stabilize it because it's going to settle, go back to a traditional, you know, coping pool and design the shell in such a way that it could handle that ½ inch of differential settlement and you know, save the client a bunch of money. But yeah, it changed the whole detailing of the project as well.
Right.
So, okay, so then let's get into kind of the granddaddy of it all, site-specific, and kind of what we really recommend as SWD for all of our jobs. What's involved in that? You know, so you've gotten your soils report, you know what's going on. You maybe have a survey showing the topography all around the area. You know, you understand, you've read the soils report, who's looked at some of the seismic history, looks at some of the overall formations of the soils in the neighborhood, in the region, and then you take that and how do you then design the pool?
Yeah, well, it's so really we pretty much do all of our stuff with you know, custom engineering, where we're drawing, you know, a detailed plan view of that structure, and then we're cutting sections through it to show, you know, the profile of the pool, the thicknesses of the shell, what the edge details look like. And sometimes we have, you know, blown up standard details in our sets that, you know, we've sort of done this detail 100 times, so here's what we think the best way is to do it for this particular job. And we would just sort of link those details back to the main plan. But you know, you should be able to kind of stand back and look at the drawing, and your steel guy should know how to steel it, your excavator should know how to dig it, and if you got to form things up, you know, what are the dimensions of the forms, and everything should be figured out on paper ahead of time. And that's really different from a standard plan, because a standard plan actually rarely even shows a whole pool, right? It's because the profile, you know, or the depths are all different. So they might just have sort of a wall detail, and maybe, you know, at the deep end, maybe a wall detail at the shallow end, or maybe there's a ramp
Normally
detail.
It's a table that I see.
Yeah,
you know,
and so you're putting together a few things, and then the, you know, different conditions on different parts of the pool. Whereas we would tend to look at it like, well, let's cut a lateral section and a longitudinal section, and you'll have, you know, two primary views, and maybe one of them cuts through the spa, so you can see how that interfaces with the pool. Or maybe that we are over digging the spa area a bit to get it into the same soil profile as the shallow end of the pool, or some other point. You know, maybe it's a little deeper, and we want those to be in the same soil so that this spa isn't hanging out in softer soil ready to sort of bend and start cracking things. So so that might mean, you know, a different set of, you know, maybe a pre-pour area under the spa to kind of fill it in and replace the softer dirt with better stuff. So that's really, you know, custom engineering, and there's nothing that's pre-approved with any city for that, because we have to do custom calculations for that. So really the builder, as you've done many times, you're getting sheets from us that have, you know, our seal on it. You're getting a set of calculations that's separate, and typically you're handing that over to the city, and they're taking 2 weeks to review it and get back to all of us on any comments. And I suppose there's something in between that too, in between that full custom set of engineering and the city pre-approved stuff, where you might have a lot of standard details, but they're not necessarily pre-approved, right? So that might be a lesser cost on the engineering side. You're still paying for the permit review and everything, so there's an additional cost there as well. But you know, at the higher end, there's really no other way to do it. And if you're getting into foundations, I don't know of any standard plan that would work with foundations very well. I mean, I suppose you could pull it off, but to me, if you got to deal with foundations, just from an analysis standpoint, I don't know how you would put together a set of plans using standards when the spacing of the grade beams is important, and, you know, the dimensions of the grade beams and how those might be connected to wall sections, other floor sections,
or grade beams
or
and tie
crisscrossing,
beams and just all of the different things that go
so
into
then
it.
it's like it's definitely got to be a custom engineered project, and maybe we're referencing some standard details, but nothing that's a standard plan per se, nothing that's been pre-approved by the city.
Yeah, and every site at that point, every site becomes very different. If we're digging in, sugar sand at the beach, and it's just going to be a spa, well, maybe we can get away with helical piles as opposed to coming out and drilling and casing and all of that. There's different situations where I know you work in the Northeast quite a bit out on Long Island and timber piles, driven piles. That's one of the things that I have learned, as we've been working together now for however many years, 8 or 10 years, is that there are multiple ways to tackle some of this, and just being able to have communication with the engineer and say, okay, here's what I'm thinking at this specific site, because here's some of the limitations. We can't get a crane in here to lift, things in. And so, as the builder, I can come in and really give you some other information that may not necessarily make it to a set of plans.
Right.
And then we work together as a team to create a system that's going to be the most cost effective for a client.
Yeah. Yeah, and I think for us, because we've been builders for a long time too, I'm kind of getting out of that, but having my guys out in the field, seeing how things are actually put together, I think has helped us as engineers, because we know constructability pretty well, and we know when things are expensive and when they're not. But sometimes we have a different way of doing things than the builder. Or maybe we started a design thinking, hey, this will be built the way Dave Penton would do it. But this isn't in Southern California, it's in Texas. And then, we start talking to a builder down there that maybe we didn't even know when the drawings went out to bid. And now he's looking at it going, hey, could I do this? Or, could I put a cold joint here because I'd like to pour the floor first? And we're like, yeah, here's how we handle that. And so then we might even go back into the drawings at that point and modify things, or do some value engineering, or just tweaking some stuff up to help out the builder from a constructability standpoint. But like all design, it's an iterative process. We're trying to work with you even all the way through construction, or even post-construction. Like you're starting things up, and I'm out there looking at stuff and
Well, I think
out.
Job that we just finished this this winter, great example. Everything was done, job was permitted, it was a caisson pool, side of a cliff. Got out to the site, started drilling, and we hit a slab of material. We had soils reports, but there was an existing pool in position, and so obviously we weren't going to blow through the existing pool. We did our borings out on the hill, and there wasn't this slab. There just happened to be a slab under probably a third of the pool, and we drilled for 5 hours on this one piece of rock and got 3 inches. And we needed to go, another, I think, 6 or 8 feet per what your guys has calced out. And so even at that point, we're already permitted, we're in construction. We had to stop everything, come back, and everything was recalculated. The piles were made larger in diameter. A couple of them were end bearing, and we reworked everything. Had to go back through the city and that. So it's when you're working hand in hand with an engineer, it's really, you can come back in and then I can rely on you. And then, the thing that I see missed a lot, whenever we're doing a custom engineered set of plans with you, we will have you guys come do site visits and do structural observation. And that's something that I don't see a lot of people doing. But to me, it gives me the peace of mind that, that you are seeing, you're interpreting, because there is some interpretation, you're interpreting what we have put in the field, and occasionally you'll come out and say, well, let's change this detail just a little bit and that. So do you guys see that quite a bit, that you guys do a lot of structural observation, or would you like to
Certainly
do more?
at the higher end. I mean, I'd like to not have to be running all over the country looking at stuff.
Sure.
But I just flew to Austin to look at one a couple weeks ago, and it's the same kind of thing. It's It's an insurance policy, really. And it's amazing. We've actually had some jobs where I thought, oh, I know this builder is going to call me out for an observation. And then surprisingly, like I don't hear anything. And a year later, he's calling me up going, we got a problem. And I go out there. And then they start emailing me the construction photos. And I'm like, why didn't you call me a year ago? Because now it's all in concrete. You're trying to hold water and it won't. And that's because this isn't done right. You know, the laps weren't right, or, you know, the wall. There was a pool that I only did the mechanical engineering on it because it was somewhat integrated with a home. So the home engineer did the structural on the pool. And I went out there and there was a ton of steel in this pool. Beautiful steel walls, beautiful steel floor. There was no connection between the floor and the walls. It was sort of like they missed the whole idea, you know, I mean, the floor had a double curtain. The walls had a double curtain on this vanishing edge. But the bars just kind of ended and there was no connection there. And I'm looking at it going, did your structural come out and look at this? They said, well, no, not yet. You know, we'll get to that. We just wanted to get the plumbing done. And I said, okay, well, you know, he may miss this, so I'm just going to point it out for you. And maybe it's in his drawings. And so I went back to the drawings, and actually the drawings had some confusing things in it. And I said, well, now I can see why the steel guy got it wrong, because the drawings aren't very clear. I said, you know, we need to add some L-bars in here. So I kind of redlined the drawings, took a few photos, and then when I wrote up my stuff on the hydraulic side, I just added in, hey, I know that I wasn't hired to do the engineering. I wasn't even hired to observe that. But I don't want to see you shoot this thing because we'll all end up in a lawsuit. You know,
Sure.
They'll just sue everybody. So, yeah, I think it's a really good insurance policy. And on these $1 million pools, what's a few $1,000s for me to drive up to Beverly Hills for a day to look at it, or even, you know, $5,000 to fly to Austin or something to look at it? It's cheap.
Yep.
You know, compared to the cost of the
When you
whole
look
pool.
at it as a percentage, you know, it's really that's what baffles me, is that it's just not all that expensive. You know, if you've got a $800,000 construction job, you know, and yeah, it's $2,000 or whatever for you to come by. I mean, what is that as a percentage? 1/4%? You know, it's the math just doesn't necessarily make sense in the long term. And I know for me, we just lay it out in our contracts that is, you know, we organize it and everything, but the client pays those fees. You know, that seems to make the most sense. So you said something that I want to touch on here as we're kind of wrapping up. You talked about, you know, splice detail. I mean, you referred to splice detailing. Let's just talk real quick about contact splice, non-contact splicing, and all of that. And I know your firm has taken a real strong stance on that. And can you kind of explain why, and explain some of the reasoning behind it, and the reasoning behind the rules?
Yeah. Well, let's just talk about a splice first. A splice is needed because you've got
and splicing. What are we
steel.
talking about?
Yeah, it's reinforcing steel. And, you know, the bars are coming in 20-foot lengths, but a lot of pools are longer than 20 feet, or the bars are lapping up the walls, so even a 20-foot pool would need bars longer than 20 feet. So we have to attach bars together, and we're not sending someone down and welding them. You can just overlap the lengths of the bars, and that's called a lap splice to connect them together. Now, if you have the bars touching each other, that's a contact lap splice. If they are not touching each other, that's a non-contact lap splice.
And there's a minimum distance between those, isn't there?
Yeah, and so if you are casting concrete and you're vibrating it into some forms or something like that, then having the bars touching each other is fine, because when you shake the concrete, it's going to flow around and grab onto those bars, right? Now, when you're shooting pneumatically, you know, dry mix or wet mix shotcrete, the concrete will hit that bar, and there's a potential for shadowing behind it. In other words, the concrete hits the bar and it kind of fans out a little bit, and potentially there's nothing back there. Now, a good nozzleman is going to move around just enough and drive material behind the bar. Now, as you can imagine, the bigger the bar gets, the more potential for shadowing there is. So what ACI 318, the building code for reinforced concrete, what it says about shotcrete, dry mix or wet mix, is that you can shoot pretty easily with number 3s, 4s, and 5s. That's 3/8, 1/2 inch or 5/8 diameter bars. Once you go to number 6 bars, 6/8 or 3/4 inch diameter, you're actually, by code, supposed to do a test panel to prove that your shotcrete crew is capable of getting the concrete around a 3/4 inch diameter bar.
And what a test panel is, we've had to do them before, is we build basically a 4x8 sheet. We just drop some bars in there, and then the shotcrete crew comes out, shoots it around these big giant bars, whatever the largest bar size is, and then we come in and core drill it, and make sure that there's no shadowing behind. The city requires that, and the actually is the either the deputy inspector or the building inspector, and most of the times both of them want to see that core sample. So
So then going back to the math really quick, if a 3/4 inch bar requires testing, imagine that if you lapped 2 3/8 diameter bars together, now you're at 3/4.
Right.
You should do a test panel. And if it's 2 number 5s, you've actually got 10/8 at that point.
Right.
When you lap them together. You
Inch
got
and a
more
quarter.
than an inch of space there. And what happens now is, so let's say the bars are, you got 2 vertical bars here, and you're shooting in this direction. It's hard to get the mud into the cleavage behind the bars here. So what the code says is that for shotcrete, whether it's dry mix or wet mix, and no matter what the bar diameter is, you should actually use non-contact splices. In other words, separate the bars so that you never have that condition where you've got cleavage behind there that you can't get the mud into. And then the code says if you're going to do that, you need them to be at least 2.5 inches apart.
Okay.
And that'll allow you to get the mud. Now you can imagine if I had bars every 6 inches, and then I have a grid overlaying another one, and I have all these non-contact lap splices, all of a sudden it's going to be hard to get the mud in there. So one solution is that rather than stacking the bars this way and shooting into the wall, you could stack the bars this way. Now you're shooting in this direction, and it's a lot easier to fill the cleavage and get complete encapsulation of the steel. But when you do that, you've got bars, you've added the wall thickness just got bigger, because now if I'm using 1/2 inch steel, for example, if they were lapped this way, I've got a 1/2 inch and a 1/2 inch, it's an inch thick total. But if I turn them this way, now it's 2 inches thick. So I just added an inch of thickness to the whole wall just to use that condition. Or I could just go to non-contact splicing.
Sure.
And I could save theoretically an inch of concrete. So different ways to do it. Some builders that were only doing contact splices took one of my classes. They went out and had to train their steel guys how to do it. The shotcrete guys were like, wow, the steel looks a little different, but they all love it now. And now what I heard is that those steel guys are doing that for all of their jobs. It's just an educational process. And in some ways, it might even make it easier to tie. I mean, Mike Logsden tells me his guys are easily doing non-contacts now. So, so that's just a detailing thing. And in our drawings, we actually have a detail that says this is what the non-contact looks like, and this is what the contact looks like. But we don't show this detail in our drawings. We don't allow for that. Now, do I freak out when I see it in the field? A couple of number 4s lap like that? No, unless I saw a lot of problem ones or a very congested area, or if I was, in a foreign country where I had no control over who was doing the concrete work and I was nervous that they weren't going to get it right, then I might say, you know what, maybe we should retie this a little bit, or separate the bars out or something.
If you remember, we had that job in Newport about a year and a half ago. We were encapsulating the shoring caissons, and just the way it calculated out and the way we had to lap everything over, we had to have so much steel in there. And you came out and did the observation. You're like, man, it's really tight. And so we came up with a way and talked with the shotcrete crew that we were able to shoot a certain section, and then this other section where we had everything congested, it was on a horizontal, and so we actually poured and vibrated that whole thing, and it was all done still on the same day, so we didn't have cold joints or anything, but it's just kind of the pre-planning. And we had done it all per the plan and all the non-contact. But when we got out there and started looking at it, it's like, man, we got double mat here, and there's a lot going on, and
Right.
It added maybe 20 minutes to the job. And the Shotcrete guy, they always have vibrators on their truck anyway. So, we just kind of redid the way we did that, the sequencing of the job. Yeah. And, at the end of the day, that was just everybody working together. It was a detail that I may not have completely thought through had you not come out and looked at it. And, but all in all, it didn't cost me any more money, didn't do anything, but we were able to give the client a better product.
Right. Yeah.
So, all right, well, thank you very much. And as always love learning from you.
All right. Thanks, Dave.
Have a good one.
Ask the Masters is dedicated to educating, mentoring, and designing a better workplace for the swimming pool industry and their families. Please take a moment to share, like, and review our content with all of those that would be interested.